Hello and welcome back to module number 8. I call this module input output of R, and I hope it will make more sense. In this last module, module number 7, we talked about what is a scan function, what is a readline function, how to read and write files, and how to access the internet or to pull data out of the internet function. We also looked at single manipulation functions, and basically what I covered was chapter 10 and 11. We also started to talk about a special package that will allow us to do more advanced thing, and I hope that you install that and you are able to run it. But back to our current module, and we are talking about input output, or I or versus O. And input is anything that sent or given to a machine or a program. Output is anything that is returned to the user. So a textbook provided a good example, and I'm taking this example from the textbook about MTA cash machine. Input, you reading your card, reading your request, and output is printing instructions on your screen or printing your receipt or sending or giving you money or taking your money. Depends who you ask. So the input in R normally has been input on a data set. Example, choose your own files, or data can run promote the user to input as well in printing to the monitor. So sometimes it asks your input in order for you to complete the task. So we will cover the following command: the scan command, the readline command, the print and the cat commands. I'm adding the print and the cat, and I'll try to make it connection between them in order for you to understand what it is entail. As I said last time in module number 7, the scan can be a function that scan the file. So the idea here is that you scan a file, text file, and what does it consist of? And so you can split each value by the scan command and give it a value true or false, or you can allow the split each value by row instead of space. So those are the functions that allowed us to do the scan. But also, the scan allowed us to leave the arguments blank in the scan function. So this will promote the user to enter the data from his keyboard into the console. So if you do scan, leave it open, you will ask the user to do that. Why is it so important? Why I'm pointing out that in that sense? One of the things that we will learn in the end of the semester is the idea of one of the new innovation of RStudio, which is the ability to run your package on a browser. And one of the things that often been used is the use of blank arguments in the scan function, so the user are able to put their request into the browser in order for it to run the analysis or to run the visualization. So again, I'm leaving it as it is. I know that it's not actually something that you are thinking right now, but when we will see the new development in RStudio, you will understand why is the blank is so important to have input by the user. So here is an example. I'm using UCLA text that was displayed in 2014 in the R user conference, and in this case it allowed us to do the following: the scan the data. It allowed us to do what, which is the list with based on age and name, and I'm leaving the name empty. And I'm going to say what is the age, and he will show me the age. What is the name? He will show me all the names in this example. The next one is read line. So it can also read the keyboard input from the user, and again, it's up to you to think about that in the long run. So the read line is mostly used to promote the message, what is your age? So it will send a given string to the console and promote the user to input. So let's start a fun one. Fun, and I'll call it a function. Answer, are you satisfied with our user? And you will have the ability to do that and be able to see what it entails. So the next function, and I want you to do that, see if it works. It a little bit remind me of HTML or JavaScript or PHP, but again, this is something that our community is really interested in input of the user in order for us to create more interaction with the user in order for us to have better input to the analysis. Print functions is the same as any other programming language, which allowed us to do a print execution of the data or the analysis. In this example, again, I'm asking the R console or the R Studio to do the print for me in order for me to understand what is the result. Some of the people have a problem to identify the result of the R Studio, and here is the resolution. Okay. The next function, which is called cat, it is been used dealing with character and string. So, example, print A and B, but if I will say to the R, I want cat and I want the ABC, and I will remember the N as a breaking line, he will give me that. So remember that /n is a breaking line in order for us to do that, in order for us to apply or to take out the quotation out of what it is consists of the ABC container. So this is just another way for us to deal with character and string in order for us to take the space of the quotation marks and leave it out of the end result. Another way for looking at that, look at the following example. The cat has also many useful functions such as setting up the string format for us to work with. And so in this case, I can format the set that it will be more concise. Instead of 5, I can set it up that it will be 5.12.13.8, and so again the format changes based on the cat functions, and again this is what is the beauty of it. The reading and writing files, and again I'm sure that you already encountered that several times in the assignment, in example that you saw online. Read function is most often used than scan because data files often have mixture of numeric and character data. So in this case, use September equal, and I'll leave it blank, function in your set of separate variable, so you will be able to do that. The issue is, again, the arguments that you embedded into your function of the read argument. And if you do not provide a good argument or valid argument, it might not be able to read your files that you want to do that. So again, look at the example, look what I have done, and go over that and see if it makes more sense. So in this case, when reading a text from a file, you can use read lines instead of read table. In this case, it will come up with actual lines of the data set, and in this case I already going to give it to you. It's called Z0, which has the those value of John 28, Mary 28, 25, 28, 17, and Jim is 19, and this is will work out in this sense. The file connection is the ability to basically, or the function or connection is the ability to essentially a file object that holds a file in an object that allowed us to call various functions on it. So in this case, you can call a file or URL, and if you call the file z0.txt and will call the file, this is what it will come out. And so again, something that in the old system, when we did not have the RStudio, we used to type this function. Nowadays, it's just a matter of choosing the right file from your RStudio that allowed us to do that. And again, if you look at the underneath functions that he uses the same function in order for us to do that. And again, when you do the read line functions, and it allowed us to specify what lines it connects and how it connects. So again, I gave you an example of seek function, and again, the seek function allowed us to seek where is the variables and how to apply to it and what does it really mean. So I hope that you will take this example and look at that in your RStudio and see what it is. The next function, it's called seek function, and the seek functions tell where the X argument file pointer is. So it will tell us how many characters from the start of the file. And this is really important. Example, in my research, I'm analyzing student essays. And so I always use the seek function to tell me how many characters are in the file that I'm trying to analyze in order for me to understand what does it entail. So the return will always be with the means of the 0, and how the value of this will tell what character the pointer was on before seeking. So that include white space. So reading from a file, here is an example. I'm taking it again from another archive data set, and I'm going to say paste, and I'm going to use it as to load the data and to write on the data. And again, each issue, what it is and consists of, how I divide it, what is the S factors look like as a false, and what is it entail, and how to create a file that call kids using the data frame as my components. Writing with cat as a function is also part of our vocabulary, and when I use that, I can apply example, I can apply true or false as my added value to the data itself. So when I save the file, after each command, it will appear true command is needed to add the lines instead of overwriting those lines, which is quite important by itself, and that's why I put it on the PowerPoint so you will have the sense. One of the things that we often talk, and chapter 11 in our textbook talks about that, is string manipulation. String is traditionally a sequence of characters, either as some kind of a variable. So the string is generally understood as a data type, and it is often implemented as array of bytes or words or anything that you can think of, and store this sequence as elements such as character using some character encoding. And when we are talking about string manipulation, and according to Bell and Gern in 1994, it is the action or foundation operation on string, which includes the creation or the destruction of the string segment, or the string matching, or the string comparison Again, depending what you are doing with regarding to replacing a substring by other string, or to add or the input or output. So those are the functions we are talking about when we are talking about string manipulation. In R, the string manipulation, we have to talk about reading the file first and then involving some numerical data or characteristic data in order for us to manipulate the character or the string. So R provides us quite many tools or functions that allowed us to manipulate the string and the character. Let's look at an example. In the first case, ignore.case string, and this function is this is where I come and laugh and see what it can do for us. So this function specifies that the pattern should ignore the case of matches. If false, the pattern matches is the case sensitive. If it's true, the case is ignored during matching. So let's look at that. The pattern, it's A and B. The string, again, I came up with different string, and the string detect is the string pattern inside. So in this case, I'm going to say, I'm going to give more the additional constraint to the string itself when I'm saying I want you to detect the string, but I'm going to add the function called ignore case as I defined above. And so the patterns is this what it will come out in the end. Another function that I'm sure that you saw in the past or saw in other people using it is the paste function, which is convert its argument to a character string. And by doing that, I'll be able to paste those values into the next function that I'm trying to apply or calculate. So it is quite clever to apply or to use the paste when you know exactly what you are looking at or what you are looking for. And by doing that, you are able to see what is the recycle of the arguments and see where the zero length argument is being recycled to in order for you to apply that. In the following example, again, I gave the letters A to Z. I did the paste of A and B to C, and I gave some premises into it, and this is what it came out of it. Another function that is really important to talk about is the grep function, and it is looking for a specific set of characters in a string itself or the element of a vector. So you can use this function in the following example. We have a data set, and the data set consists of a combination between a character and numerical value. And in this case, I'm going to say something really interesting. So I'm going to use this function. I'm going to use the pattern, which will be the cat, and I'm going to say what it will be able to pull out of it in order for me to display it. So in this case, he will count only three cases out of my data set. And so if I will use this function and again use the ignorant.case and I will say it's true, it will show different set. So again, this is the beauty of how we can manipulate a string in order for us to get the information we are looking at and how to be specific in our request. The next two functions is basically determine the size of each element of the character or to leave it empty. The nchart is the function determine the size of each element, and the nzchart is the test whether the element of the character vector are non-empty string. So in this case, the n, I'm using the first example, the nchart and I'm calling it X, I'm going to say the type is char, and will allow an A, which is non-probability, and which will be false. And so in this case, this is what it will come. If I will use the other example, and I will try to determine what it allowed us to do, it will allow us to, again, add more value to it to see if it's true or false. And again, I want you to remember, this is an added value to the character in each function in order for us to determine if it's an empty string or something that has some value to it, and we can add those value to it. String_t is another function that allowed you to format the string, and this is something that some of you already complained. So in this case, I can apply some idea of values. The square of %d is the %d, and I'm able to add some components to it in order for me to have what is the sequence of 8 with regard to 64. So the percent sign tell the computer to look for a value to place the string and the d as an integer. And those are components that I'm using in order for me to make my arguments more forward or understood by the R. And so again, look at that, read the text on it. The split is again the idea of how to split string into values, and it is very useful to dates math or time math. And so in this case, if I have a date, example 6/16/2011, and I will ask us to split it, something that Microsoft Excel does not allow us to do, or SPSS do not like it to do, in this simple function, I can do that, and I can again divide the date, the month, and the year into 3 separate components in order for us later on to use that in our analysis. And if you look at me and say, hey, this professor is bold, is that in the past we did not have this function. So I used to do that manually. And if you have 1 million records in your data set, this function is a very helpful function. The R has many functions or many tools. I'm not going to cover all of them, but I hope I did some introduction to the functions that you are going to use or create for yourself. So I want you to experience those functions and tools in order for you to solve the problems that you want to do in your own R package. So this was introduction to functions and tools in order for you to see where you come in and how to apply that into your own package and your own understanding. I will give more heads ups about the project as we go along, but this is all for now. The last issue that I need to talk and I want to talk about is the package that is not discussed in our textbook. And it is one of the most useful packages with regard to overall overview of the application on the assignment. And so I'm going to allow to split data and run function that will split the section and combine it back to the original set. So the idea of the package is again more functions, an example of what we are trying to achieve in R on the R community with regard to functionality of the package. So what is this package can do? First, it is a syntax as across all functions. So instead of having to load 5 packages of each type, it allowed us to have all the function in one package. So it makes it a best choice with regard to function. Those functions inside are most useful that focus around the function of apply, which is the basic use of a loop in OR. So control structure, equal, not equal, greater, and so on. I'm sure that you are already familiar with this syntax. So if we will take the if statement, and if statement, the syntax is if condition is true, otherwise else condition 2. For example, if z1 equals 0, if we will print, otherwise we will do the conditions. The loop, again, is the most common use in R, but while apply the loops, we might have into problems and might have idea of how to encounter problems with that syntax. So again, this is the loops in R, and I'm sure that you curse at the loop that we try to look at and try to do that in the example. So let's look at a simple example of a loop and see what it entails. If I have I'm using the iris dataset, and I will embed it as one container, and I will say no, and I will create an empty container. So in this case, this is what it will provide me. This is what it will allow me to do. An example of a condition, again, the X, I gave it a container, Z as a null, and by using it, I'll be able to apply a function or write a function as an if condition. And by doing that, I will be able to see if the Z null, as I declared in the beginning, and I will write my functions, I will be able to see what is in the end, what those functions consist of. Okay, so this is the basic, we cover that already. Under the package, the plur function package, it will allow us to do the format, and so the data frame will allow us to put it into a list and apply it to a data frame. And so in this case, this is the data frame. This is what it will look like in that set. And so using this package, we will be able to do summaries. We can able to do the min count, and we will also call it the min count and what is it stand for. So in this case, it will be much more concise when I'm using that structure in order for me to get out of the data. So look at this example, apply to this example, apply that in order for you to understand what does it entail, how to apply that, and what it is and consist of. And again, look at the shortcut this package provides us. When we are applying it, we are counting on it to do that. The full function of this is found in whoa, it doesn't function, so I'll find a new set. He changed the example. I'll look at that and try to the data set. This is the things that I need to apply, and this is where it all comes down. This is the person who created. He doesn't exist anymore, so maybe he moved to another place. So I will I need to cite the example or thanks to the people who created it. I'll post it with a new update. They changed the website quite often, so I do need to cite and thanks those people who created those things. Until next time, I hope this module was helpful. I hope that this example will helpful. I'll post more information about that. Until next time, I hope you enjoy it. Bye.